Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing, we are making a playlist, and in this playlist we are solving all those questions related to data structures and algorithm, which are related to each other, so that we can able to build pattern and able to solve all the questions which are related to these concepts intuitively in the contest as well as in the interview. So I will suggest that you can start solving the question from the hash one, or you can also watch the videos from hash one as well, so that as you will see the next video, you will able to get the intuition how to solve the next question. So let's start solving this question as well. That is palindrome linked list, and obviously you have to watch the previous video as well for solving this question, like for getting intuition. So in this uh, in this question, what we have to do, we have to check whether a linked list is a palindrome or not. So if you don't know what is palindrome, let me tell you that. So palindrome is something which is same as which is same as from the start and end as well. So let's take a string that is sis. So this is in palindrome because from the left it is same and from the right it is same, like you have listened about in your childhood. Now let's try to take this linked list. So linked list will going to be 1 is connected to 2, 2 is connected to 2, and another 2 is connected to 1. So obviously this is palindrome because if you will see it from the left and right, it will be same. So now what we have to do, we have to check whether a given linked list is a palindrome or not. So we have to return boolean as a data type, obviously. So let's see how we will be solving this, and obviously we are on a two pointer approach, so we will be solving this using two pointer. One pointer will going to be slow and another pointer will going to be fast. So now I would suggest that you can like pause the video and try to solve this using two pointer approach, where one will be slow, another one will be fast. So now let's start to see how we can solve this. So obviously what if we will be doing, we will be making two pointers. One will be pointing to one and another one also be pointing to one, and slow will be pointing one step at a time and fast is moving two step at a time. So in this way, what's our goal to like do this, so that we can able to find the middle element of the linked list, 1 to 2 1. So we will able to find this. Now what we will do, we will separate this linked list and reverse it. So now this is the required. Now what we do, we will compare these two, and if they are equal, then we will be returning true, otherwise we have to return false. So this is the simple concept that we will be using here. And in the previous question I have already told you how to reverse a linked list and how to find the middle element. We can using this slow and fast pointer. So obviously we will be moving slow one step at a time and fast two step at a time, and eventually the slow pointer will be pointing to this and fast will be pointing to last element or the null element, based on the length of the linked list. So let's start solving this as well. So first what we have to do, we have to make two pointers, or we can say we have to first handle the edge case, where if a head is equals to null, sorry for this, head is equals to null, or head dot next is null, which means there is only uh, one element. So in this case we have to return false. And now let's start solving this. So first we have to make two pointer. So list node slow is equals to head, and then list node fast is also be pointing to head. Now what we have to do, we have to like find the middle element. For that, let's start in while loop. While fast dot next, fast does not equals to null, and another condition will be fast dot next should also not equals to null. In this case, what we if this condition satisfied, then what we have to do, we have to move slow pointer one step at a time. Sorry, so slow is equals to slow dot next, fast is equals to fast dot next. Now after doing this, what we have to do, we have to separate the linked list, sorry, this from 2 and 1, so that we can check it for the palindrome. Like after reaching here, we have to separate this and reverse it. So for that, what we can do, we can make two pointer. So list node current, which will be pointing to slow dot next, or slow. We can point it to slow. That will going to be 2 in the for the first linked list. And now what we can do, we can make a previous node, list node previous, and it will be pointing to null. Now what we have to do, we have to start in while loop. While this current does not equals to null, now in this case what we have to do, we have to first make the next node so that we can do this continue for the next node as well. So list node, it will going to be next node. Let's name it as next node. Now we will be like pointing it to current dot next. Now what we have to do, we have to point current dot next to previous, which is currently null, and then we can make previous as current, and then we can make current as next node. So what it does, let me tell you. So suppose we are currently on 2, and then it is connected to 1, it is connected to 2. So first it will point this current to null, and then it will move our current node to 1, and it will point this to 2. So this will look like 1 is pointing to 2. So this is the way to reverse the linked list. Now what we have to do, we just have to check the two linked lists that we have just separated out from the original linked list, and we have to check whether they are palindrome or not, and we already reverse it, so we just have to check it from the head. So the head of the original linked list is head, as we haven't changed it, and the head of the new linked list that we have separated out will be previous, as this previous will be pointing to the last node, as we are moving previous to the current and current to current dot next. So current will be pointing to null in the last, and previous will be pointing to the head of the separated linked list. So what we have to do, we just have to check while previous does not equals to null. Why we are checking for previous? Because it is smaller, obviously, in both of the cases, whether the length of the linked list is odd or even. In both of the case, either it is equal or less in size. So we can check using this. So while previous does not equals to null, what we have to check, if previous dot value, if that is become equals to does not equals to does not equals to head dot val. So if we have find any element which are not equal, that means that the given linked list is not a palindrome. So in that case, we have to return false, and otherwise we have just have to move our previous and current head pointer. So previous is equals to previous dot next, and head is equals to head dot next. So after doing this, in the last we have to return true, because after this while loop, if we haven't able to find any node which are not equal, which means that this current linked list is in palindrome. So we can return true. Okay, now we can like try to run this and check. Okay, so all the test case have been processed. Now we can try to submit it as well. Okay, so there is an issue. Let me check. Okay guys, so the issue is here we haven't moved our fast pointer to 2 steps. So that's why the issue is coming. Now we can try to run this. Okay, let's submit it as well. Okay, so there is another issue, which is head is pointing to 1. In this case, we have to return false. We are return true. We are returning false. Okay, let me check. Okay, so if there is only one element, then obviously it is palindrome. That's why we can return true. Sorry for that. Now we can submit it. Okay, so we have successfully solved this question. See you in the next video. Bye.